তো সবাইকে নতুন একটা ভিডিওতে স্বাগতম। তো আজকে আমরা ফিজিক্স অলিম্পিয়াড ন্যাশনাল একটা কোশ্চেন সলভ করব ক্যাটাগরি সি এর। তো আমাদের তাহলে এখানে হচ্ছে আমাদের মূল প্রশ্ন হচ্ছে বলতে গেলে পাইপ এবং ভি এবং আয়তন রিলেটেড কোশ্চেন। তো তাহলে বেশি কথা না বলে সরাসরি অ্যান্সার করা শুরু করি। আর একটা জিনিস বলতে চাই, যেহেতু এই কোশ্চেনের ক্ষেত্রে আমাদের কোনো ট্রান্সলেশন দেওয়া হয় না, তখন বাংলা ট্রান্সলেশন দেওয়া হয় নাই, তার মানে তোমাদের সোজা কথা ন্যাশনাল অনেকগুলো কোশ্চেন তোমাদের ইংলিশে জানা থাকা লাগবে, অর্থাৎ তোমাদের বেসিক ইংলিশ ভালো থাকে সেটা তোমাদের মাস্ট জানা থাকা লাগবে। এবং সেই কারণে আজকে এই সম্পূর্ণ ভিডিওটা মনে করো আমি বাংলা জায়গায় পুরো ইংলিশে কথা বলবো। সো যদি কারণ বুঝতে কোনো সমস্যা হয় তাহলে কমেন্টে প্রশ্ন জিজ্ঞেস করো, আমি সলভ করে দেবো ওখানে। দ্যাটস ওয়াই তোমাদের যেহেতু ন্যাশনাল রাউন্ডটা ইংলিশে থাকবে, সো তো বাংলা ট্রান্স থাকতে পারে, বাট অনেক সময় বাংলা ট্রান্সলেট ভুল হয়, তো বেশিরভাগ ক্ষেত্রে তোমাদের ইংলিশ ট্রান্সলেট জানা থাকা ভালো। তো সেই কারণে তোমাদের এই পুরো ভিডিওটা আমি ইংলিশে বলবো। ওকে, দ্যাটস ইট। সো তাহলে আমাদের কোশ্চেন তাহলে শুরু করা যাক। So the question কি বলা আছে? So number 3, know the elegance for a certain fluid, an experimentalist finds the amount of fluid flow V through a pipe is related to the pressure difference X between the pipe and satisfies a power law scaling relation V equals to APB, where APA and BE are constants. The following data where the data points were obtained, P and V, the table has been given to us. And the number A question is there are more questions for this one. I'm just solving the first ones. It's only A, so yeah. How should one modify the original relation given above so that the fit can be done in terms of a straight line? So what is the question asking to us? It's asking about if you are to modify this equation v equals to APB, what do we have to do so that the fit can be done in terms of a straight line? That means, what do we know as v equals to APB? What does it show? It's a exponential equation, okay? V equals to a p to the power b. It's the exponential equation, okay? So what we have to do, we have to make this exponential equation into a linear equation. That's all there is. So yeah, basically that's all that we have to do here. And for this equation, we have been given some points where p and v values have been given to us. So yeah, basically that's it. So what do we know actually? How do we actually get a straight line? I mean, our like linear equation from an exponential equation. So that's what that's the first thing we have to know for to answer this question. So what do you have to do? Always remember that whenever you have to transform an exponential equation to a linear one, always use log. That's it. And the opposite is also true. If you have to like translate a linear equation to an exponential, same thing, just do a log, just do a log transfer. That's it. Just bring some logs on the equation and that's it. You can easily solve the whole equation that way. So what do we have to do? We are just going to do the same thing. We are just going to bring log on both sides of this equation. In front of v, we are going to bring a log v, and in front of APB, we are going to bring another log here. Okay. So I don't have the space, so I'm just going to write everything from the beginning so that it will be easy for you to understand. So yeah. So let me just write everything from the beginning here. So yep. Okay, here we go. So what's the equation? V equals to a p to the power b, right? That's the equation that we have been given here. Let me change the font size to a bigger one so that you can easily see that. So yeah, v equals to a p to the power b. So what do we have to do now? We have to just bring the log on both sides, so that way it will be easy for us to understand. So yeah, now I'm going to bring log here. Log v equals to, what do we have to do here? What do you think? Like, now the log will be on the whole, on the both of these, okay? The whole equation should be on log. So log, there is the bracket. It didn't work that way. Okay, log a, and what else? P to the power b. P to the power b. Now, do we know how this log works? I hope you all should know that. So now what is going to happen here? We can just write like the same thing here. Log v equals to log. We know the formula of log, right? What happens if you see the multiplication of two variables inside the log? Of course, it's going to get separated and they're going to stay as additions. So what do we have to do here? Log a plus log p to the power b, right? P to the power b. That's what happens. And what do happen when you see the inside functions as like p to the power b when they're in exponents? Of course, the exponents. What is going to happen to the exponent is going to come at the front before log p. So what do you have to do here? Cut the p of b and just keep the p here and take the b at the front. Okay, that's what it's about. So yeah. Now what do we have? We have like log v equals to log a plus b log p. So how does it make like the linear equation? Do we see something similar here? Like something maybe? What do you think? Like anything that represents to like to the linear equation? Maybe not now, but what happens if I were to do it something like this? Let me just grab like maybe have this log v, maybe just assume at this log v as y. Okay, just think of this log v as y, and b and log p, think of this log p as x. Okay, and since there is b all is multiplied to log p, so what we can do, think of this b as m. Okay, and you can see there is a plus here, so keep the plus up here. So yep, and think of this log a as c, the constant or the variable that is used to look at the y-axis. So yeah, here. So what is it? Does it look similar now? Yes, kind of. How? Because if you were to look at carefully, you can just like easily see that here, this equation is equal to y equals to mx plus c, right? That's what this equation actually symbolizes here. And of course, we know what is mx plus c, right? Mx plus c is the equation for a linear equation. So yes, that's how this log function, I mean this log equation becomes a linear equation. Okay, so that's how it works. So I guess now you have got like a good idea about how we can actually transform a log, an exponential equation to a linear one. So yeah, that's how you do it. You can also do the same thing. Just if you have like a linear equation like this one, just use log on both sides and do the same thing, just the opposite way. You will get the same answer here, like v equals to pb. Okay, same thing, just the other way around. So yeah, that's it. So I hope you got all these things about how y equal to mx plus c works here. So yeah, now what do we have to do? We got the linear equation here. Log b equals to b log p plus log a. Now what do we have to do? We have to figure out the values here, because they also what do they want here? They want the how should one modify the original relation given above so that the fit can be done in terms of a straight line. So what do we have to do here? What is this question asking to us? So we have to just use these values here, p, v, substitute v and p from these values to figure out the values of log a and b, so that we can just write a normal equation like y equal to mx plus c, not with the log ones, just like normal equation from the v of b from v equals to pb to this one. Okay, that's what we're gonna do. So what do we have to do now? We have to just figure out the whole thing from the given points. So what do we gonna do? What I'm gonna do now is that just erase all this thing here. So now what I'm gonna do, I'm just gonna substitute p and the values of p and v in this equation. So what is gonna happen is gonna give me another. It is gonna give me another list of values of p and v and a and b. Actually, not another value. Like it's just gonna give me another value for log a and b, just b, not the log a, just a and b. Okay, so that's it. So yeah, let's do this now. So yeah, so I got this table for all of you. So now what did I do? What did I do here? What do you think? So the basically what did I do for in this table is that I just separated the value of P of V from here. You can see this is the same value 1.1, 2.05, 1.9 to 4.4 is the same value for P of V. And what did I do? I figured the value of log 10P and log 10V separately for each value of P and V. Okay, for each value of P and V, the for each variables the value differs. Okay, so that's what happened here. So that's also well that's all that I did here. So each value like for P 1.1, where's the value of log 10P is 0.04. For 4.4V, what's gonna be happen for log 10V is gonna happen like 0.6435. So that's it. So that's what I did here. Okay, so this is what I did. I figured the value of log 10P and log 10V each respect to the value of P and V on each point. So yeah, that's what I did here. So now I have the value of log 10V, I have the value of log P for each points that have been given to us. But what else am I missing here right now? I'm missing the value of A and B. So how do I figure the value of A and B? What do you think? So we have like a lot of options to do this. So what I'm gonna do, I'm just gonna do the same thing here. So I'm just gonna take like two values of from here, like 0.27888. I'm gonna substitute log P with this value and log V with this one. Then I will have an equation where I will have like only log a and log b and just b. So you got the equation part, right? I'm just gonna create like two equations like that. Then I'm gonna use these two values to have another equation. Then gonna substitute with the other. That's gonna substitute those two equations with each other, and we're gonna get the values of a and b. That's it. So like how am I gonna do that? So instead of talking, let's just do it. You can get that easily that way. So okay. So what I'm gonna do? What am I gonna do? I'm not gonna get the log v value first. So I'm gonna take the maybe first this one. Log v is equals to 0.3 0.3118 equals to log a. We don't know what is the value of log a, so keep it as log a, and plus b, and log p value, what is the value of log p is 0.0414. Since let me just change the font to a bigger font, so yeah, now we can see that easily. A little small, so yeah, now it's better. So yeah, now I can just put the v at the back of this equation. So yeah, now we got first equation. I've got our first equation. What is that? 0.3118 equals to log a plus 0.414b. That's our first equation. What's the second equation? I'm going to use these two values. 0.2788. That's the log p. Okay, so that's log p. 0.6435, 0.6435, which is the value of log 10v equals to log a. Same thing I'm going to do just on both sides. So it's going to do here 0.2788 b. That's it. Okay, so these two are our equations. So what I'm going to do, I'm just going to give this one our first equation. So let's make this is our first equation. Okay, hold on a second. Here we go. Equation 1, and this one is what is gonna be equation 2. So yeah, now what I'm gonna do, I'm just gonna substitute both equations from a with each other, or like positive, negative, whatever you want. So from this equation, I'm just gonna get the answer of both sides, and one of these is gonna be log a, and another one is gonna be log b, just b. So from this one, I'm just gonna substitute. I'm just gonna do positive, negative from both sides in order to save you time and skipping those parts so that you can easily find that out. Okay, you can just figure this out, right? Because if you know how to do log, you should know how to use the substitute method here, or whatever method you can want. So anything up to you. So from here, I'm just figuring out the value of log a from here. So what is it gonna be? Let's see. So yeah, that's it. So from there, I got the value of log a equals to 0.233. I use calculator for that, just so you know. So yeah, you can use calculator on physics Olympiad. So not on the math Olympiad, just on the physics Olympiad, you can use calculator. Okay. So that's why I use calculator for the to figure the equations, figure the answer for log a. And now from the equation, I'm gonna find out the answer of just a, not a log a, just the answer of a. I'm gonna find out that, and from the equation, I got the answer of b2, which is equals to 1.470. So now I'm gonna find out the value of just a. What do you think is gonna be the value of a? So it's going to be just 1171. Okay. So that's the value of A and B. Okay. So what do we think? What do you have? So do we have everything right now? Yeah, we do. We have the value of A. What is A here? A is the C, the plus C, the C in linear equation. What is B here? B is the M of linear equation. And we have the value of B and P for everything. So yeah, that's it. So what are we going to do? Are we done? No, we are not. We still have to do something else. So we just change these things from here. So yeah. Now we have this space from here. I can use the space from here. So what are we gonna do? Just gonna do the same thing. Now we gotta answer everything right now. So now we have to write it in the linear equation, so that the find and what is the linear equation? Let's remember that again. The linear equation is equals to y equals to mx plus c. Okay, so now we have to write it in this way. So what is y here? I already told you, which is log v. So what are we gonna do? Are we just gonna write the answer of v or log v? What do you think? What do you think I should use, log v or just v? Of course, it has to be log v. Why? Because the variables are v and p, not ab, okay, not just v, okay? Because these are variables, so the answers for v changes here. So that's why, and the inputs is v and x here. So of course, these two are changeable. That's why we're gonna use log v here. Just gonna what is gonna change is the m and c. That's it. So for m, what am I gonna write here? 1.47, which is b, 1.47. So that's it. And what is gonna be x is gonna be the log p. So yeah, log p. And plus c, what is c? What c is the a, log a, which is gonna be around 0.233. I basically didn't need to actually find out the value of a. We actually need to figure out like for no reason. But yeah, that's it. So I guess yep, that's it. So we can just write the equation like, so we can just write it down. Since they asked like how should one modify the original relation, you can write it down like if you have to add like log on both sides, and make this equation look like log v equals to 1.47 log p plus 0.233. You can make this equation. So we can make this original relation in a way so that the fit can be done in the terms of a straight line. So yeah, that's all this is about. I hope you get that. So this question wasn't really about like physics question. It was basically about like math, kind of little to math. So yeah, so that's what it's about. I hope you get that. See you in the next video. And if you have any questions, feel free to answer that. Feel free to comment that on the comment sections. I can just reply whenever you want. That's it.